The half-life of thorium-229 is 7,340 years. How long will it take a sample of thorium-229 to decay to 20% of its original amount? There are a few things we have to think about to work through this problem. First, I need to realize that this will follow an exponential decay model, which will look like this. I'm going to need to find a value for k. And I know k is going to be negative because it's exponential decay. So what I'm told is the half-life of thorium-229 is 7,340 years, which means if I start with an initial amount, A naught, and I wait 7,340 years, I end up with 1/2 of it. So for this value of t, I end up with half of the original amount. I can use that information to find k. I end up with half of A naught after 7,340 years. So I plug in 7,340 for t, and I would get out 1/2 of the original amount. Well, even though I don't know what A naught was, I could imagine dividing both sides by it. And now I have an equation I can solve for k. I'm going to imagine rewriting this as a logarithm. So k times 7,340 is equal to the natural log of 1/2. The exponent is equal to the log of the base of the other side. Dividing by 7,340, I find the value of k. Okay, so let's see what that is. So the natural log of 1/2 divided by 7,340. All right, I get minus 9.44 times 10 to the minus 5th. So I'm going to go on and write that without the scientific notation. So I imagine moving that decimal place 5 places over, and I have this very, very small value for k. That allows me to rewrite my function. A of t was equal to A naught E, and now I have a value for k. I can plug my actual value for k into the original function. And this gives me an actual model for the decay of thorium-229. All right, so now I can actually answer the question I was asked. How long is it going to take? I'm looking for a value of t where I'll end up with 20% of what I started with. Well, thinking about that, I want to start with A naught. I want time to advance some value t until I have 20%. So 0.2 times A naught, 20% of A naught. All right, this gives me an equation to solve because, well, I want to end up with 20% of the original amount, and now I have a function on the other side. Just like before, I can imagine dividing out the A naught. So I never really need to know what A naught was to be able to solve this exponential equation. Well, I've gotten the exponential part by itself. I can imagine taking the natural log of both sides or just rewriting this as a natural log. The exponent, minus 0.00000944t, is equal to the natural log of 0.2, right? The logarithm of the base taken of the other side. So t is equal to the natural log of 0.2 divided by minus 0.0000944. This will give me a very large answer because thorium decays very slowly. So it'll take about 17,049 years for thorium-229 to decay to a point where you only have 20% of your original amount.